presented this at DevOps in London last week. I won't go through the whole bit, but I'm kind of proud of some of the animations I have in the slides. I'll show you a little bit. So the talk I had, I talk a lot about Lucene and what makes Atlas Search similar and what makes it different from other search solutions, and then we'll start building some basic queries. And then if you're interested, we can talk about the architecture, because that's going to help you understand performance. But that might be a little deep, so we'll do this. But the talk I give, all of this is flexible, of course, but the talk I give has this soccer theme to it. Have you seen my soccer app written? So I have this app in soccer, Atlas Search Soccer. If you go to it, it's not on your phone, like it's not responsive for the phone, but it's on a website. And you can build your Feed the Dream Team. So I wrote it because, and I call it Atlas Search Soccer, and it's weird because wherever I go, they're like, they look down on me because it's not soccer, but we're in Dallas. I grew up in Rockwell. Sorry, I know
That's
this is
harsh. You came to Dallas.
That is a good catch, though. But when I grew up in Rockwell so many years ago, like nobody played soccer. 0 people played soccer because we were playing football. But now my husband's French, and my first husband, I don't know if I ever told you I was married before you, honey. He's German, and so my family, they're always into like the World Cup and whatever. And then they talk about these players, and I don't know what they're talking. Like it's hard enough for me to manage what he's saying in English, and then I got to figure out what all these players' names. So does anybody here follow soccer a lot? Oh, great. Then you can like help find these players.
Are you suggesting that because of the Cowboys, we should start following soccer?
It hurts. It
works.
Yes.
It's been 27 years.
Thanks for the reminder.
I was there.
So before I was I've been at MongoDB for 5.5 years, and I was on both Scott and Britton's team, and it's really amazing to be here with you guys. So anyway, I'll just say that. And this is where I was before, but today I'm going to consider myself a coach. I don't know too much about football or soccer, but I do know a little bit about Atlas Search, so you can consider me your coach. So any application that has a search bar needs search, but even if it doesn't have a search bar, it needs search. And so this always looks simple. It's quite complicated. I'll talk about why people think it's simple, why people think it's complicated. You think it's simple because it's just like a search bar, and you should just be able to put something in and get it. But it's complicated because users are on the other side of it, and they don't know how to spell things. They don't know what they're looking for. They don't even know they're in the market for things often. So the goal is, whenever I sort of build an application, I always think about it as like the search game. So I'm going to coach you today on the strategies implemented to win at the search game. And the search game, you're playing right when this little search bar becomes like this giant goal, like a goal so big that you can't miss. It's just sitting right in front of you for a duck. And your users are going to find everything they want with it. So when you win the search game, so this is an application I want to show you guys. So if you win the search game, likes, people follow, and then everything goes up and to the right, essentially. But in order to win at the search game, you need to have the right players. And the first player you need are documents. We all know MongoDB documents, hopefully. So they're strong and flexible and fast. But the great thing about documents is they really set you up for the real MVP of search. And so whether you're using Atlas Search or any other solution, you really should be thinking about these things. This is not the real MVP of search. This is the MVP of everything but search. The real MVP of search is Apache Lucene. So all the big successful search solutions, they all use Apache Lucene. It's open source library. It's been around for decades, and it does everything really, really well. It has one big power play. So inside of your document database, MongoDB, your document database, your data goes through a process called analysis, done by analyzers that produce tokens. It's going to cut up your data and produce tokens. And those tokens are stored on an inverted index. So your inverted index is going to hold those tokens, the data that's broken up. It's going to hold those tokens and the document that it was stored in originally, and along with other sort of metadata, frequency, position, score numbers, etc. So that's the big play. Every solution has this inverted index, and so this is why. So an inverted index is basically like the index that you have in the back of the book. So if you were to look for, so the terms would be, if you're looking for out, damn spot, and you look at the entire works of Shakespeare, you wouldn't read all the documents, all the pages in the works of Shakespeare. You'd go straight to the back index at the back of the book and look it up there, and that would point to the documents that it's in. So essentially that's it. I'm going to walk through a play with that in it, but now you know that search uses an inverted index because when they make that query, they read the index, not the documents. And then MongoDB uses normal database queries are super fast when you use the balanced B-tree index. So to discuss the difference between them, I'm going to show, if we were looking through these MongoDB documents, Manchester United, Manchester City, Newcastle United, and Paris Saint-Germain, and if I were to look through these MongoDB documents for the terms Manchester United, the standard analyzer, we have many different types of analyzers, I'll show you this. The standard analyzer is our default analyzer. That's going to remove punctuation, lowercase everything, separate at the white spaces, and Manchester United becomes Manchester and United. Now this, when we go to the inverted index, the inverted index will say Manchester maps to documents 1 and 2, and United maps to documents 1 and 3. So that's basically how the inverted index works with the MongoDB index. Lots of different analyzers. They all cut the words up in different ways. So we have standard simple keyword whitespace. I have a website to show you some of the differences in that. Languages, we have over 40 different languages. So I mentioned standard lowercase is everything and breaks the white spaces. The English analyzer is interesting because it understands common nuances of the English language. So if you look for something, if you look for books, and if something says book, it'll recognize that same thing and it'll return a match. It also recognizes tenses, like driving and drives will map to each other. And then, of course, every language has that as well. So the type of analyzer matters because your tokens matter in this sense. So I'm going to show an example. Actually, let me... I go to Atlas Search Soccer. So this is my dream team, and if I'm looking for different players, I'll get to this in a second, but I have this ability. So this is going to show you facets. The application. Let me just show you real quickly how the application works. If I'm looking for a player, if I'm looking for Messi, I have 3 different types of ways that I query him here, but I have many other ways. I just only implemented these types. So as you start writing, it will give you the code here that you want to copy as you're writing. So if I do Messi, there's the code. I don't have wildcard-listed text. So I said I want to put him in this place so I can see more about the player. I have more like this operator in there in the code for that. If he looks good to me, I'll go ahead and add him to the team. So if you have this on your computer, you could build your own team, and it's written to your local memory, so everybody's team is different. But back to the indexes. If I were to do, I'm going to pick my analyzer. If I were to look for Manchester United here, and I'm using the standard analyzer, I want players from Manchester United. It says I have 697 players from all over, and they're from Manchester United, but they're also from Manchester City, Leeds United, West Ham United, anything with either Manchester United. If I were to use the keyword analyzer, nothing changes. The keyword analyzer takes Manchester United, keeps it at Manchester United, and sorry about that. That's me. If I were to do Manchester United and use the keyword analyzer, hopefully this will work this time. Yeah, then I have 33 players, and they're all from Manchester United. So it's important. Like these are things, I'm going to show you how to create an index in a second, and it's going to go really fast. But it's important to put a little consideration into it for reasons such as this. So keyword analyzer at Manchester United, and then it maps to only one document, Manchester United. So when you're thinking about search solutions, you need to think about, and when you're building your own search queries, think about your indexes, think about the technology underneath, and think about how they work together. We used to, with MongoDB, if you wanted to have a search solution with MongoDB, we had text, we had regex, we had different ways to do it, but it was cumbersome and unpleasant. And so lots of our users would use Elasticsearch or Solr or any other third-party system, but they were using Lucene on the other side. So we just took Lucene and we built it into Atlas Search. So I can talk about the architecture in a bit if you're interested. But that's
you're using Elasticsearch.
We use Elasticsearch.
Okay, go back one slide, because one of the things I was talking with one of our PMs on Atlas Search, and so Elasticsearch is built on top of it, but they were built on top of a very, very old version of it. And what they ended up doing is making so many changes in Elasticsearch. They're probably I think he said 6 releases behind where Lucene is, and they can't catch up because they customize it so much. So their search, from a Lucene perspective, is way behind what we're using in this. They kind of lock themselves in by customizing an open source product, so they can't adopt new versions of it without going and revisit, like you were saying before. I got to revisit all these applications that are using it. So.
And I'm interested in how, because I know that a lot of people who set these up, you have 2 different systems. You have to manage and scale and secure and keep the data in sync, and it's all a giant headache, and you're never really comfortable with anything or sure about where everything is. So having it all in one place is one data set that you get used from is really nice.
But Apache Solr and Apache Lucene work quite well together.
Yes, because Solr
is
built on top of Lucene, right?
Yeah, and they're both from the Apache project, and they both communicate real well.
And so Elastic is more managed than Solr. Solr requires you to write all the sort of management around.
Elastic's AWS thing and all that, they're custom
Well,
stuff.
they're an actual company, so they've got their own stuff.
Yeah.
I was talking with one organization, and they had a group of 5 individuals. Their whole job in life was taking a dump of the JSON dump from their core database, whatever it wasn't Mongo at the time, and then they would index it. Once that index was built, and it took several hours to get the index built, sometimes overnight, then they would swap it into production, and then it was the whole process over again, because the process to build the index is very slow. So one of the nice things about this, we do it all for you behind the scenes. So you're not having to deal with all the ETL transformation and stuff. And when you get into, are you going to talk about synonyms? Or?
I can, yeah.
Okay. But the way we do synonyms is different as well. So if you add a synonym, you've got to rebuild that whole index if you're using Lucene. With ours, we've externalized the synonyms, so they're in another collection. I can just add to that collection, and it's automatically picked up. So I, have eliminated a lot of this GORP, work that has no value, other than trying to make the product do what it's supposed to do. Sorry, I didn't mean to steal your thunder.
No, actually, but you're talking about indexes, and I'm about to create an index, so maybe I'll just do that now. So we have our data in Atlas, and we want to create it, prepare it for search. There are 3 steps to do it. You need to have your data. You need to create the search index, which is going to tokenize your data and put it on inverted index, as I showed. And then we query using $search. So with that, let's go look at the data that we have. So I found this data set on Kaggle. It's the 2019 FIFA data set. It has almost 20,000 soccer players, and each one of these documents is, it's very, has about 100 different fields. It's very flat, but you can nest it or whatever you want to do. And we have data across time and strings and numbers and all sorts of different data types that you could have in it. So to create the search index on this collection, you could use an API, or you could go in here. I think you could go in here. Oops. Search index. I don't have any indexes. Create the search index. the JSON, you can use that. We'll use the visual editor just to walk us through the whole thing, make sure I'm on the right collection. Now, this is where I can specify that analyzer that I'm using. I'm going to use the Leucine standard analyzer, but I can change it if I wanted to be any of these other things. So I'm going to use the Leucine standard analyzer.
Can you add a synonym? Or when it says soccer, you can put football or both?
I can add synonyms. Actually, I'll show you the synonyms in a little bit.
Oh,
I'm
sorry.
going to open up this
Just
this
go
window. No, I'm going to open up this window
I would.
because, well, I mean, because I actually have. So for soccer, it's hard for me to find synonyms for like players because I only know Zizou. I don't know like any other players that I could do like synonym for if you guys use Zizou, but I do have synonyms implemented in this application, so I can show it to you in a bit. So here I'm going to use the two things I want to call out here are I use standard Leucine analyzer and I map dynamically. So mapping dynamically, let's go ahead and create the search index. That's fine. I could do the synonym mapping and set it there. Short
Messi.
field.
So wouldn't Messi and goat be the same?
Not if you're French.
I'm not French.
Yeah.
Oh, sorry.
I have to say, so you know the company Vercel. So their CEO is he's from Argentina, and we had it before the World Cup comes on. He was being kind of. He is like Argentina's France is overrated, Mbappe's overrated, which is sacre bleu chez nous. Huh? So we were like, that's outrageous. And he kept saying, and I was nervous, and the whole house is nervous. And I'm like, he thinks that it's not even going to be close. Argentina's going to blow him out 4-0. And that's just rude. I mean, right? So I'm like,
4-0.
Argentina's going to beat France 4-0. And I said, well, I think France is going to win. It's going to be close, and there's going to be drama at the end. So I go to yoga. When the game starts and I come out at halftime, I come out of yoga at halftime, I check the score, and it's 2-0 Argentina, and I'm thinking, we're both tracking correct right now. So he won, but I was closer in the bet, so whatever. Anyway, so now we've created the index. So now that I've created the index, we query by $search. Is everyone here familiar with the aggregation pipeline? Has anyone built aggregations? Okay, good. So it's just, it goes through different stages and you get results. So when you build search queries, it's an aggregation, but $search is the first stage in your aggregation. So if you're familiar with aggregation pipeline, you're familiar with MongoDB, you already need to know everything you need to know about doing $search. So let's go here, and I'm going to build my first query. I created the index, so here is that player database. Do you guys use the aggregation pipeline builder at all in your aggregations? I'm addicted to it. I almost can't do anything else. It's just so easy. So this is in Compass. You could do it also inside of Atlas, but I'll do it in Compass. So you can pick your stages. It gives you nifty, helpful hints. My index is named default. I'm going to query for
How do you pronounce that?
Mbappe.
I was just giving her a hard time.
I like to do Mbappe because my last name has an accent on it as well, and it took me 20 years to figure out you had option EE to get that accent on the end. So
How the heck did you do that?
So I get Mbappe, but if it was 18 years into this marriage, I would have spelled it like this, and I would get nothing because E with an accent is spelled differently than that. So the first bit of search magic is why you'd want to do this is with this simple line of code. Next edits, you can have more. You can forgive people for their
Have a
mistypos.
happy marriage.
Yes, that's right. And if we want to give them a lot of freedom, I would have max edits too. But then my answers wouldn't be. So this is like I get Mbaye and Hape, and so the one thing that I keep coming back to every time I implement search is that I no longer feel that I am like there are all these different tunables. So I don't feel that I'm a search engineer as much as like a search artist, because there are all these different things that I can do to feel my way to the right search result. All these little editables I do. So I do max edits 2 or 1, and then I can add all other things on there as well. And because it's an aggregation, I can combine them with other stages. So I have 100 different fields. I want to limit the payload, not just for my users, but for myself. So I'm going to use project next. So just get back the fields I want, and I want to use short name. So I just get that, so I don't need 100 fields. And the other interesting thing is I'm going to use the meta operator. Oh, yeah. Okay, so here I use the meta operator to get the search score out. So I use meta because the score is not in the original document. And the score in all Lucene solutions, it's going to grade Atlas Search, and Lucene is going to grade all the 19,000 players based on a relevant score. So how well the query that we had for Mbappe Max Edits 2 matches the document, and we get these scores back. Now these scores are based on relevance, how well they match, and they're returned in descending order. So this Atlas is already returning to us the best matches first. And because we're getting the best matches first, the final stage I'm going to use is limit. If I'm getting the best matches first, there's no reason for me to continue going over the rest of the payloads. Let's just say I'm going to limit to the top 6 players. In fact, I can even limit before I get to project. That way I just get the top. So I'm pointing out that the scores are already sorted, because sometimes people sort after the score. So there's no need to do it. If I put limit on top of it, I'm just going to get back the best matches, and then I can project versus projecting those there. So lots of different tips there. Yes, sir.
So if you go back to that,
Yeah.
it's this meta and doing that. I'm looking for, like, if you were searching for a word, and you needed, so like in Solar and stuff, you search for a word, and you get back also, you can get back the surrounding context.
Yes.
Can we do that here?
Yeah. So there is some.
Please, can you show me?
We can do. Let me look. I don't have. So I'll give you these.
So think of it like in the description, and there's probably
So for instance,
soccer.
here, if I were to do highlights, you're asking for highlights, right?
Yeah, something like, hey, I want to show, well, really the result back is, here's your hits, relevancy, but here's the word, and then there's like 5 words before and 5 words after you, so you have a context you can look at and see.
Partial search.
Well, result back, and not partial search. So you find pasta exactly like pasta, but then you want to, not to highlight, I want to see in the one field, like say the field you're searching is a description. So in the description you see the word pasta, and then you want to see like 5 words before it and 5 words after the word pasta.
Actually, let me show you something.
Yeah, that's
It's called. So it's going to tell you. So I have something called atlassearchworkshop.com. This is something I'm just going to show you. Then I showed you earlier. This shows. Actually, this kind of shows you how to build out this movie search application. Now in this one, this is what we've already done. So this is, maybe it's the next lesson. The next lesson, which is lesson 3, I talk about highlights. So I have, this is the project stage, meta search score. But if I wanted to, in this movie application, I use meta, so I use meta for search score. I could use meta for search highlights. So I create a field called highlight, and I'm going to get my highlights back. And in order to do that, I'd have to say highlight path full plot. So let's see if I go back to Mbappe. Let me remember what that looks like. I can never remember this, which is why I write the asset after my text. Text, comma, highlight, add. And then do. Honey, it's never really this hard, just so you know.
No, this is awesome. Thank you.
So here we have, this is going to be simple because I'm just looking across this word. But if I open this up, it's going to show me, the highlight is giving me an array, and inside of that array, I should get, it's going to give me the word, and it's going to give me text, or it's going to give it a hit, which means I want to put it in yellow. Actually, let's see if I can look across long names. Maybe that'll be better. Long name, and let's look for a more common name of Ronaldo. Let's look at the long name here. Okay. So, if I look for here, I should have more. Let's see. Yeah. So here it'll show me Ronaldo. It can be a hit, which tells me I need to highlight it or whatever, and then the words around it, it's going to say it's text. So I can open up this value, I get these arrays, and then I can see. So in the front end, I usually...
So how many words around it does it, or can you set that somehow?
I don't know if you can set it, but...
Well, I'm going to actually...
I'm going to get on my representative, because this question's been out to them for a long time. And I'm going to say, I have this person, I went to the meeting, and
Well, see, it's kind
he
of...
answered it just like that. And
Now, you've got an Atlas subscription, right?
Yeah, I have meetings with them once a week. We've now
But
gone
you haven't
to
to CSM, but one thing you can do is open up a Jira ticket, it's a support ticket, ask some questions like that. That goes directly to CSEs, and they are very, very in-depth. I mean,
I believe they
CSMs
did all this with us, whoever our reps are. We had like 3 people, so.
You could always just ask me. Any friend of Alan and Scott's, they're a friend of mine.
Well, now, yeah, well, no, I'm just going to brag now and saying, oh, I got someone who really giving the answer.
Well, they also wanted the video, so. You know.
Oh yeah, actually I do have. I should make a video for that. So anyway, that's a basic. So it's nice to know. You could build search, and if you're familiar with aggregations and all the options, it's pretty easy just to get something back like that with a couple lines of code. So we have lots of different operators on that workshop. I showed a few. But the operators are important to pick out. I use text. When I created that default index, it indexed all sorts of data on top of just text data. It also indexed dates and numbers, and it can index inside, words inside of arrays and embedded objects, etc. And so, because of that, there are lots of different ways to query your data as well. We have regex, we have phrase. So in the workshop, one of the examples I give is Harry Potter. So Harry Potter is, I can query for text, which is going to find Harry or Potter, but I can also query it as a phrase, and I can see how far apart these words need to be, and that'll change the results altogether. Again, you're an artist and with your search. So, and so having these different query operators is a little bit like every user has their style on how they want to look for their data, autocomplete, etc. Facets is another nice one. So does anyone want to kind of play Stump the Chump? Do you want to cut? You're the soccer fan. You want to come and play?
No, yeah, but.
Come on. We'll go super fast, I promise.
Yeah, so.
We'll go pretty fast.
Okay.
So here, does anyone know like a really complicated player? Because I could give him a really complicated one. I could give him that one.
Aubameyang?
So do you say Aubameyang?
Yeah. I'm very.
Do you know how to spell it?
Try.
Okay, okay. Because if you do, it kind of breaks the game.
Oh.
What lesson was that on in your workshop, team?
3.
Lesson 3, okay.
So did it come up like?
So is that him?
Yeah.
So
Oh,
you
yeah,
misspelled it, but it was that. So then I didn't know you from Gabon. I thought he was French. So I think everybody's French. So it's 20 years of brainwashing does it. So we could add him to the team. So there's one thing I want to do. Actually, let's reset. I want to show one more thing. I showed the. Why don't we look for Ronaldo? So we all know the Ronaldo. Go ahead and hit enter. We all know the Ronaldo we want for our dream team, but he's not there. Because again, this is sorted, this top red number here, that's your relevance score. But we can do things if we want to, in this overall score, that's the FIFA score that it gives you. So I told you Atlas Search brings back the data in terms of how relevant it is, but if you want to affect your search results so that a field has influence on it, we have a couple different score modifiers. In this one, I'm going to, what is your name?
Kiran.
Kiran. Kiran's going to implement function scoring in a second to allow the overall FIFA score to affect our search results by hitting this function score button there. And so now this is added, so you see in the code here on the right, this is added to the relevance score, the FIFA overall score, and now Cristiano, even though he's difficult, he's the highest rated FIFA player, and so now he shows up to us first. So this is great for things like sponsored searches, or in the restaurant application that I have, if you have restaurants that are high rated, and you want that to show up first. And then I place this guy, I guess, with him. And the other thing is, something that you might explore when you're ready is faceting. So if I were to look for, there's this goalie, and he's from Poland, and his name is Szczęsny.
Yeah. Disney.
Yeah. So let's look for him without looking for him. So you can say he's Polish. Well, actually, let me do something. Let me take off function scoring here, so it doesn't show up. Let me clear it again. So yeah, so look for Poland. Actually, go ahead and hit search right now and just see what happens. So a couple things I want to show is I'm using, so I'm looking for players from Poland, and you can see how they're kind of broken up on these different teams here. So this is faceting. So if you show how your results are kind of spread apart across things, that's lesson 10 in the workshop, but I haven't written it. Maybe I'll write it this weekend. But if you wanted the code for that, that's here on how to create that. You have to write another index and write the code for that. So that's something this app can do for you. But we're doing Poland, and we're doing, what is it, goalkeeper?
Yeah.
And so the other thing I want to show is that now each of these creates I call them search building blocks. Like I'm looking for Poland and nationality. I'm looking for goalkeeper and player positions. And I can combine those search parameters together in the compound operator here using must, must not, should, and filter. So these both use filter. Go ahead and hit search real quickly. That should work. So this is getting Polish, so these are all Polish goalkeepers, but you see that they all have a relevance score of 0. And it's because inside my compound operator, I chose to use filter. If I use must, that would affect the score. Filter is kind of like a match in MongoDB. So it means it's in or it's out, but it doesn't contribute to the score at all.